Hello, today we're going to be looking at a review of oxidation number rules. This is something that we did way back in formula writing, like for instance how to determine the Roman numeral to name a compound. For instance, like copper Roman numeral 2 sulfate is actually using rule number 3 of the oxidation number rules. Like, how do you know it's copper 2 sulfate and not copper 1 sulfate? Do you just look at the periodic table, or is there some rhyme or reason behind this? Well, it turns out if you're going to figure that out, like for instance copper sulfate, if you take a look at this formula that's right here, the reason that we know that that's copper Roman numeral 2 is because there's only one sulfate here. By realizing that sulfate is -2 off my reference table E, I multiply the numbers on the way down, and 2 times 1 is -2. I'm going to set that equal to 0. So because of this compounds rule, rule number 3, compounds have to add the total charge. When you multiply the charge and the subscript together, when you multiply these together, you should get 0. Well, -2 times 1 is -2. The missing number must be 2. There's only one copper in this formula, and that's why this is copper Roman numeral 2 sulfate. So in different scenarios, you use different rules. So if you notice, I wrote the rules in shorthand. That number 1, always look for elements. That's when you have one capital letter with no charge. If it has one capital letter and no charge, over its head, you would assign a 0 when you're looking at an equation. I also then look for exceptions. So when doing a worksheet, I can fly through a worksheet because I do these in this order. Find the elements. You're looking for one capital letter, no charge. Give them all a 0. Go to the next thing, exceptions. What do I mean by H is -1 after a metal? Well, here's an example coming right up here, that if we take a look at a metal, like for instance Na, and we throw down an H, well, the only thing Na can be is +1. And using the compounds rule, we know that that forces, since there's only one of these here, that forces the H to be -1 since there's only one in there. If you look at the math on the bottom, this is what you wind up with a statement. So that's the compounds rule once again. So the exceptions kind of tie into the compounds rule. That's why I kind of do these side by side so that you can see it. How do you know compounds add up to 0? Well, if you think about it, you have a glass of water, you drink it, you don't get shocked. Why not? Because the overall water has no charge. Inside the water are things that are charged. The H and the O are charged as individuals, but as a group unit, they have no charge. So I just wanted to point that out. So what is a peroxide? A peroxide is something like H2O2. When you have a 2-2 relationship, this is an example where, since H is going to be +1 when it starts a formula, remember H is only -1 in this one scenario. Otherwise, H is usually +1. So if you see a worksheet with compounds starting with H, you can just give them +1 right off the bat. That's how easy this is. All right, so just keep that in mind. H is +1 normally. It's rare to find it -1. The only time you'd find it -1 is after a metal. A peroxide is when you have a 2-2 relationship, and hydrogen peroxide is the most famous one of all. If the H is starting the formula and it's +1, notice it's not this scenario up here. It isn't that. It's not that. So it defaults to +1. Do the math on the bottom, compounds rule. You have +2 here, that forces this to be -2. And if you realize that it's going to add up to 0, divide the 2 back up, you get -1. So that's just a proof right there, just to show you why you can't have the normal numbers. Let me just show you what, if somebody wasn't paying attention and they just shoved in the periodic table numbers for H2O2, and they had this and they had this. This is wrong, totally wrong. Because when you multiply down, what you're saying here is this: 2 minus 4 equals 0. Now, hopefully, you know that is not true. If you are going to argue with that one, well, then there's going to be some serious problems because you really need to go back to old school math. But I don't think anybody's in that scenario. Just remember, compounds have to add up to 0. And the last rule is when you have a complex compound, for instance, if you had something like CuSO4, all right, what you can do is you can pluck the SO4 right out of the equation, set it equal to the charge found on reference table E, and that is the table E charge. When you set it equal to that, then you use your normal number for oxygen, multiply on the way down, you get -8, and think about what the missing number is. 8 to 2, think about it on a number line. How many spaces do you have to move? You have to move 6 spaces. And since there's only one sulfur in this formula, that gives me the individual numbers for the sulfate. So to wrap up, my number was +2 from before. That was the compounds idea, because sulfate as a group was -2. There was only one there. Then I just did the individual pieces of sulfate. There's our total numbers. So the oxidation numbers, these are what we're going to be determining. And that's how you go about doing this. Why is this so important? The chapter is called Redox. And redox means that there's a change in oxidation number. So we have to know how to assign oxidation numbers within a equation, because if we don't know how to do that, then we're not going to see the change that's going on. I'm going to demonstrate for you in a couple of reactions. This is where we're going to in the next couple of days. So I'm hoping that with what I'm doing with the rules will make sense. If you have any questions, feel free to ask me. And set up a Google Meets if this is going too fast for you. But anyhow, we're going to take a look at the oxidation number rules. First rule is look for elements. Do you see any elements in the first equation? Give you a second to look at that. See if you see any elements. Do you? Of course you do. You got this guy right here and you got this guy right there. Next up, we got the compounds. All right. Well, I'm going to start with the easier of the two compounds. I know that Mg can only be +2. I know that O is -2. I'm going to use the compounds rule to figure this out. 4 times 2 is -8. 2 times 1 is +2. Missing number here, +6. Now, since that's sulfate, that makes that +6 and -2. I can now multiply on the way down. I got -8, +6, and I got to add up this whole compound to add up to 0, and that gives me +2 for that. All right? So if we take a look, we can actually see why this is a redox. Take a look at this right here. Now, some people will say to me, hey, Mr. Zakari, I can't tell if the number went up or down. Let's think about a number line. Here's 0. Here's 2. Did the number go up or did the number go down? When you're going this way on a number line, that is an increase. And if we call increases oxidation. Okay, if you're going down, then that is going to be a reduction. And here's the guy that's going down. Okay, so it's very important that you understand which one is the oxidation, which one is the reduction, because we can't go much further if you don't understand how to apply these numbers to a equation. Next up, we're going to have another problem right here. All right, oh my God, this looks like we're going to start with elements. Do we see any elements? Yes, we do. We got an element right there. Next up, do we see any exceptions? Oh, yes, we do. We have the one where oxygen is -1 in a peroxide. Since H starts the formula, it's +1. The H starts the formula is +1, and this one's -2. You can actually see the redox that this oxygen both went up and it also went down. So we'll be talking about that later on down the road, but today we're just looking at oxidation number rules and how to apply them. That last equation that we have here, looking for elements. Do we have any elements? Of course we do. We see that. We see that. Why? Because they have one capital letter. At this point in the game, we're reaching the end of the school year. You should know what an element looks like. So that's an element. Next up, we got two compounds. Well, we got hydrogen is in this compound. Hydrogen's always +1. I'm looking for exceptions. I don't see any. O is -2. I know that O is -2. I know that Al is +3 because I got that right off my periodic table. Using the compounds rule, I can figure out what HNO3 is going to be because 2 times 3 is 6 and 1 times 1 is 1. Missing number right here is 5. And there's my oxidation numbers using the compounds rule. Again, this is nitrate over here, so I don't need to do it over again. I just know that nitrate is always going to be the same charge. Hopefully, guys, that was helpful. Remember, do the problems in this order. Elements are 0. Look for the exceptions on a worksheet. Do you see a metal hydride or do you see a peroxide? If you do not see any of those, then just go right ahead and give H a positive 1 anywhere you see it in a compound. O would always be negative 2 in a compound except in a peroxide. So if you scan a worksheet or a page for any of those 2 exceptions, that will help you speed through your trip. The last 2 are the compounds and the polyatomic ions rule, which I demonstrated for you. These are a means of trying to figure out what the charge is when you have more than 2 elements. Number 4 comes in really handy because you can just pluck something out. Here's another example, just in case that didn't make sense. If you had something like NH4, NO3, on this one, the first thing you do is you'd say, all right, well, I see 2 polyatomic ions here. Here's NH4. You're going to set it equal to a positive 1 charge. Why? Because that's what table E says it is. H is always positive 1 in compounds, okay, unless following a metal. N is not a metal, so there we are. Positive 4 minus 3, and there's my nitrogen in that one. All right, if I wanted to do the other one, it's real fast, real simple. All I have to do is set NO3 equal to the charge that's on table E. NO3 is equal to a charge on table E of negative 1. O is always negative 2 in formulas and compounds. Negative 2 times 3 is 6. Missing number 5. Wait a second. Mr. Zakari, didn't you get the same number before when you did nitrate down below? Positive 5? Look at that. Why is it the same? Because it's nitrate, guys. It's nitrate here, it's nitrate here, and it was nitrate when I did it up here. All right, so just keep that in mind, that right there, this cluster is nitrate. It adds up to negative 1. The charges are always going to be the same. You do it once, you've done it all the time.